Make sure before you start that you do have a copy of the blank notes from my website or pencil and paper to take notes on. I will be looking for you to have notes in your own handwriting available to show me in class. There is a pause button, and please use it whenever you need to take a moment to take some notes. I suggest use the pause button now to look at the 7.1 objectives. We are going to be doing quite a few things in 7.1, so this would be broken down to at least 2 small lectures. We're working with sequences and series in Chapter 7, and 7.1 is mainly an introduction and learning some different notation and talking about recursively defined sequences. In the first section, we'll be working on A and B in the first lecture. Just a brief introduction of what do we mean by a sequence. What we're going to do in this one is just use an example of someone named Johnny who puts $50 in the bank, and then each week he adds $120 to his account. We can use the following sequence to view this numerically, and that is the first week Johnny has $50. That's all he put in his bank account. The second week he has $170 because he added $120. The third week he has $290, and the fourth week he has $410. And we could keep going on and on and on. And what we want to do is think of this as 1 pairs with 50, 2 pairs with 170, and so on, or simply write it as a set of ordered pairs. There's a set of points here, 150, 2, 170, and so on. The general term, or an equation for this particular sequence, could be a sub n is equal to 50, that's his first week, plus 120 times n minus 1. N is actually these numbers right here. The ones on top. So each week the number goes up, and we can put that number in for n right here. So let's tell you a little bit more about sequences and series. There are these sequences to start with. Here's your definition. You can fill in put this on pause and fill in the blanks on your blank notes pages or take some notes. You do need to know these terms. A list of terms can be generated by a formula, which we call a general term. Another word for formula is equation. We have things that are called finite sequences and infinite sequences. What do you think is the difference between the two? Please include an answer for this question on your notes. Some definitions for you on the domains of our finite and infinite series or sequences. The domain, the numbers we're going to put in for n or for x, the first term, is the set of all positive integers starting with 1. You can think of them as counting numbers, and they go on to infinity. The domain of a finite sequence actually stops at some number n. Here's an example of a sequence. Here's our general term. A sub n is equal to 2 to the nth power. And if we put this, if we want to find some of the terms of the sequence, all we're going to do is use our sequence right here, put some subnumbers in for n, starting with the number 1, because that would be our first term in the sequence. Put 1 in for n, so I have 2 to the first power equals 2. My second term, which is my a sub 2, is equal to 2 squared, or 4. I put 3 in for n. This is my third term in the series, or the sequence. And it's 2 to the third equals 8. Now I can find my fourth term by putting 4 in for n, so 2 to the fourth equals 16, and I could keep going on and on forever doing this. Here's an example of something you may get on your homework. Here we have a general term. A sub n is equal to -1 to the nth power times n squared. So we're going to do the same thing I did before with this sequence that's a little bit more complicated. And all I'm going to do for my first term is put in a 1 for wherever I see an n. So my first term in this sequence is -1. And then I'm going to continue on for the first 4 terms doing the same thing. For my second term, I put a 2 in wherever I see an n and simplify. My third term, I put a 3 in wherever I see an n, simplify. Fourth term, 4 in wherever I see an n, simplify. And I have my first 4 terms. The next part of the directions on this particular problem, it says to find the 23rd term of the sequence. So I'm simply going to put 23 in for n and simplify. I get -529. This type of sequence is known as an alternating sequence. Why do you think that is? Please answer this question and bring it to class in your notes. We will ask this question during class. Now this is the toughest part of this whole 7.1. And that is, we're going to be given some numbers and we have to predict or guess what the general term is. So we have to write our equation. All of our equations are going to start with a sub n equals, and we have to look at the numbers given and try to figure out what could be the general term. Sometimes there's more than one answer. So when I work on these on tests and quizzes, I will use yours equation you came up with, and if yours works and it's different than mine, you'll get full credit. But what we're going to do these, we're going to look at this and we're going to say, think what is happening to n. We're going to put n in and come out with some number for a sub n. So we're going to start with 1. So what could we put? So what general term could I have? If I had a sub n and I did something to 1 to get 2. Well, I can think of, perhaps 1 plus 1, and that would work, and that would give me 2. But would 2 plus 1 work? That does not equal 4. So I'm thinking, these are not, this 1 plus 1 is not going to work. So I'm going to start over and delete these and think, what else could I be? It's not 1 plus 1 or 2 plus 1. We're not adding 1 to each number. Oh, wait a minute. Could I do 2 times 1? 2 times 2? 2 times 3? What I'm thinking here is writing 2n as my general term. 2 times n. That gives me the first 2 terms. 2 times 1. 2 times 2 works. But 2 times 3 doesn't work, does it? So 2 to the n doesn't work. Or 2n doesn't work, but how about 2 to the n? Let's see, 2 to the first power equals 2. So that works there for one of them. How about 2 So the second power equals 4. That works for the second one. 2 to the third power equals 8. Okay, so I have, that worked for all of them, didn't it? So I'm going to go ahead and say my general term for this is 2 to the n. Hopefully I haven't confused you too much. Let's go ahead and look at this next work. What is happening to n? Remember, n starts with 1. I can put another number in here. I have 4 terms this time. And I'm thinking that I'm just taking the square root of n each time. So I'm going to write my general term for this one is a sub n is equal to the square root of n. That one was pretty easy. Let's see this one. What is happening to n? This is 1 times 1. This is 2. Oh, not sure about this one. This is pretty tricky. I want you to work on C and D for class. See what you come up with, and we will go over C and D at the beginning of class. You could put, this is the end of the first part of our lesson. And the next part is on series. See you in class.